Hello and welcome to Physics Teacher. In this live session, I am going over an exam review for the grade 10 academic science course. I'm going to go over different types of questions from biology, chemistry, physics, and there'll be some climate change at the very end. If you have any questions, you can let me know in the chat and I will get to them. If you can't stay for the whole session, you can watch the live session anytime you like as a video on my YouTube channel. Just go check out the channel and subscribe as it helps. All right then, let's get started. We're going to do some true and false questions for each unit and then we'll move on. First, biology, true or false? And if you know the answer and want to let me know in the chat, go ahead. True or false? Number one, cellular respiration occurs in the nucleus of the cell. This one is going to be false. Does anyone know where it actually does occur, cellular respiration? It's not in the nucleus. Anyone remember what the powerhouse of the cell is? It's the mitochondria. All right, question two. All plant cells are green. This is also false. If any of you have ever eaten a carrot, which I assume you have, you know they're not green. So no, not all plant cells are green. Plant cells do not use oxygen. Oh, these are all false. Yes, although plants do undergo photosynthesis, they also undergo cellular respiration. Okay, so those are all false. Okay, let's try some chemistry for true and false questions. Number one, on the periodic table of elements, elements in the same group, that's our columns, have the same number of orbits. I seem to like false questions, don't I? No, as you're in one group, you have the same number of valence electrons, but as you go down, your number of orbits actually increases. So no, that's false. They have the same number of valence electrons. All right, question two. In a chemical reaction, a metallic element usually loses electrons. Okay, let's take a look. Take an example like sodium. Sodium has only one valence electrons. So is it easier to lose one or gain seven? Yeah, it's going to lose it. So yes, we have a true and false that's true. Yes. Okay, that is true. Question three. The attraction between oppositely charged ions is called a covalent bond. No, I thought we were going to have another true, but we don't. That is called an ionic bond. Covalent bond is the sharing of electrons. Okay, so the attraction between oppositely charged ions, which you would have with a metal and a non-metal, would be an ionic bond. Okay, let's try some true and false for physics. Question one. Magnifying lenses produce virtual images with a diverging lens. Okay, this one is very tricky. Magnifying lenses do produce a virtual image, and yes, all diverging lenses produce a virtual image, but a magnifying lens produces a virtual image with a converging lens, and it's done when the object is brought closer to the lens than its focus. Okay, so again, false. If you're writing one of my exams and you don't know the answer, maybe just go with false. You seem to have a better chance. Question two. A normal is a line that is perpendicular to the reflecting surface. Okay, this is true. That is what a normal is. Number three, when making a ray diagram, the minimum number of rays you need to draw in order to locate an image is 1. Okay, here's the false. No, that is false. Okay, in order to find the image, you need to find the intersection of these rays. And to find an intersection, you need at least 2 rays. Okay, you can't find an intersection with only one line. Anyone have any questions? No? Okay. Multiple choice type questions then. We'll start with biology. Number 2, we have 2, 6, and 9. Number 2, the specialized parts of a cell, that's important, of a cell, that carry out specific functions are called. We have organs. Organs are not even part of a cell, so you shouldn't even be thinking of that. Golgi bodies, okay, they're inside of a cell, but they're very specific. Organelles, that's the one we want. Because a Golgi body is an organelle, and they're all different types of organelles that each carry out a specific function. Okay, so our answer will be B. Question 6. The tissue type which covers and protects the human body is connective? Nope. Nerve, muscle, there it is, epithelial, right? For example, your skin, your epithelial tissue. Number 9, this is getting into plants. Which of the following statements about xylem is true? Xylem transports solutions of sugar. They do water, but there can be nutrients in that water, but primarily water. So I'm going to say most likely nope. Water and xylem can be transported, yep, up or down, no. Only up. So this is no. Xylem may contain chloroplasts if exposed to light. Nope, you don't magically create polar chloroplasts just because you're exposed to light. Mature xylem cells are not alive. Yes. You get new xylem every year. That's what creates the rings in like your trees or whatever. All right. Next is chemistry. A reaction that absorbs heat energy. So it's taking heat energy from the surrounding environment. All right. Let's just ignore these two. It's going to be either exothermic or endothermic. Exothermic means to release heat energy. Endothermic means to absorb it. So we're going to go with D. Okay. 16. An example of an ion with the same number of electrons as neon. Okay. So neon. I don't have a periodic table. Hold on. I have a periodic table on one of my slides. Is it 10? Okay, so neon has 10 electrons. Okay. Let me bring this over so we can use it. All right, so neon has 10 electrons. This is nitrogen. So nitrogen is here. It has 7 electrons, but then has a charge of -2. So it gained 2 more electrons. So 7 plus 2 is 9, not 10. Okay, oxygen. Oxygen is here. It has 8, but it's gained 3 more. So 8, 9, 10, 11, not 10. Fluorine's right here. Fluorine has 9, but it's gained 1 more. That's 10. Looks like the answer is going to be C. Let's just double check sodium. Sodium, why does sodium have a charge of +3? I don't know. I also don't know why oxygen has a charge of -3 or nitrogen -2. But either way, yeah, that doesn't make sense. All right, C. Next, which of the following compounds is composed of molecules? So molecules are made from compounds that have molecular bonds. Molecular bonds are between nonmetals and nonmetals. So here we have metal, metal, metal. So no, no, no. There we go. Propane. Okay, nonmetal, nonmetal. There's a molecular compound. There's a molecule. D. Okay. Any questions with our chemistry multiple choice? No? All right then. Physics multiple choice. What must happen to an object in order for incandescence to occur? It must be coated with mercury. No. That's probably looking at fluorescent light bulbs. We have like a mercury gas in those. No. It must be placed inside a light bulb. Actually, no. We do place like tungsten inside of a light bulb under a different gas so that when you heat it to extremely high temperatures, it doesn't oxidize. And it will last a lot longer than, say, 20 seconds. But it doesn't have to be. You can still get things to glow by heat, even not in a light bulb. Like imagine your stove top, when you turn that on, it glows red. That's incandescence, but it's not inside of a light bulb. But I've already said the answer in explaining that. It must get very hot. Yes, it must get very hot. D says it must have electricity put through it. Nope. No, it doesn't need. As long as it gets to that temperature somehow, it will glow. It does not have to get to that temperature with electricity. Okay. 36. Which of the following is luminous? So luminous means you create your own light. A tree doesn't create their own light. The moon reflects the sun's light, so it doesn't create its own light. A pond, again, reflects light. A flame creates its own light. Okay. Last multiple choice. You are holding a flashlight, so the beam strikes a plane mirror at an incident angle of 38 degrees, so as shown right here. What is the measure of angle x here between the reflected ray and the mirror? Okay, so for physics, for reflection, the law of reflection, the angle of incidence, which is here, is equal to the angle of reflection, which is here. So 30, I don't know why I was about to write 35, 38. Okay, and the normal is always perpendicular to the surface. So x, therefore, would be 90 degrees minus 38. So our answer is 52. Does anyone have any questions with our multiple choice? No? All right then. We'll move on. Okay, next type of questions we're going to do is labeling. A lot of them will be biology. That's the way it is. So first we have two types of cell. We have a plant cell and we have an animal cell. Okay, should be able to identify which is which. Here's your plant and here's your animal. So let's label parts of the cell. So we're going to start with the plant. This part here, this one is the chloroplast. This huge one right there, that's not the nucleus. A lot of students like to say the big one's the nucleus. This here is the nucleus right here. This big one is the vacuole. That's our storage sac. Now we do have vacuoles in animal cells, but they're not this big. You can see them like right here. There's a vacuole. Okay, and then this supportive structure around it is our cell wall. All right, so animal cells, they do not have a cell wall. They have a cell membrane. Now be careful, because a plant cell also has a cell membrane. It's like right inside the cell wall there. Okay, so an animal cell does not have a cell wall, but they both have cell membranes. Then we have our mitochondrion. Okay, and like I mentioned before, plant cells also undergo photosynthesis. No, sorry, cellular respiration. Plant cells do both. Animal cells do not do photosynthesis. So if you look inside the plant cell, we can also find mitochondria in there as well. Okay, moving on. Here we have our Golgi body. I'm just going to call this the ER. It's our endoplasmic reticulum. And finally, just the space or the jelly-like substance that all the organelles are inside of is our cytoplasm. That would also be for a plant cell. Then we have our nucleus. Some students write nuclear membrane. I'm okay with that because, yeah, the surrounding membrane is a nuclear membrane. So you can write nucleus or nuclear membrane. I would accept either one. And finally, these are used in mitosis. They are our centrioles. Okay, moving on. More stuff to label, and not surprisingly, biology. So we have to figure out the respiratory system here, all the parts of the respiratory system. All right, so we have our nasal cavity. So that's where we're going to start. Okay, and then this connects to, we have two tubes here. You have your esophagus right here. That's not really part of the respiratory system. But what we will have is this part here, which is called our epiglottis. And that will close the trachea when we're swallowing food. When we're not swallowing food and we're breathing, it'll stay open so that air can come into our lungs, down the trachea. Okay, and then you have two bronchi. We have a bronchus. And then into more branches, like a tree, we have bronchioles. And then we have these little tiny air sacs we call alveoli. And the muscle that helps us breathe is our diaphragm. Okay, and finally, it's not directly part of the respiratory system, but it is important. Right there, that's our heart. All right, moving on. More biology to label. Okay, so this is our digestive system. So we put this in the other diagram, but here we have our esophagus. So food's going to go down the esophagus. Okay, into, here we have our stomach. Okay, and then that continues into your small intestines. And then into your large intestines to absorb that water. Okay, so small intestines is where you get all the nutrients absorbed into your bloodstreams, and then excess water with your large intestines, and then we have our rectum. Okay, this one here, food doesn't actually go through it, but it's very important for the digestion of different foods. This is our liver. And if anyone was curious, right there, that's our appendix. Okay, did I get everything? Yes. All right, looks like we're done with systems for animals. Now we gotta look for plants. So this is a leaf cross section, and I love to ask my students on this too, and I asked them this on a test. Could be on the exam too, so make sure you know it, is to 1, label the parts of a leaf cross section, and 2, say how each part contributes to photosynthesis. So first we have this little waxy layer on top called the cuticle. So how does that help with photosynthesis? Well, it prevents water from evaporating from the leaf. And the leaf is where you're going to have photosynthesis occurs, and photosynthesis needs water. And if it just all got evaporated, that would not be very good. So our waxy layer helps with that. Okay, right here, all of these is called the palisade layer. And there are a lot of chloroplasts in the palisade layer where photosynthesis will occur. This is your upper epidermis. Okay, here we have our spongy mesophyll. So there's lots of room in our spongy mesophyll for gases to be exchanged, and that's important, right? Because we need to take in carbon dioxide and expel oxygen. How are we going to take it in and expel them? Well, we have right here our stomata, which will help with that. And that will be open and closed with our guard cells. Okay. Now finally, the cuticle does help prevent water from escaping through evaporation, but how do we get the water? We get it from the roots, and they get brought up to the leaf through our vascular bundles here, which contain our xylem and our phloem. So make sure you can label that and explain how each one contributes to photosynthesis. All right, more biology, but this is actually done in our physics unit on optics. So we are going to label the eye. So we have different parts. Here we have the iris. That's the color part of your eye. Okay, and then you have this hole in the iris. That's the black part. That's your hole. That's our pupil. And then we have our lens to help focus the light. That's our lens. And then you have this very thin, transparent layer. That's called our cornea. Then this white part of your eye, here and here, that's our sclera. Then at the back, you have your retina, which contain your two types of light receptors. You have your color ones and your black and white ones, so cone cells and rod cells. Okay, and then right here you have your optical nerve, right, which is going to take that image formed on your retina and change it to an electrical signal to send to your brain. But notice that right here, there's no retina. So this is your blind spot. No image can form there. Okay. All right, I think we're done with the labeling. We're going to do some short answer, and we're going to start with biology. All living cells in our body must perform cellular respiration. So when we were doing the leaf, I talked about the importance of photosynthesis. Now we're going to talk about the importance of cellular respiration to provide them with energy. Explain how the digestive, respiratory, and circulatory systems are all involved in providing cells with the material needed for cellular respiration. Okay, well, digestive system. For cellular respiration, we need glucose. So the digestive system is going to provide that. Our respiratory system. Okay, we also need oxygen. So our respiratory system is going to provide that. So what's the circulatory system do? The circulatory system is going to transport the glucose and the oxygen to every cell in your body. Okay? So I wrote that answer there. And that's going to give you carbon dioxide, which again then your circulatory system is going to bring back to your lungs to exhale as waste. And then you get water and energy. All right, chemistry. In grade 10, we do a lot of nomenclature in chemistry. I did make an entire video that's pretty long on all the nomenclature you need to know for grade 10 chemistry, which is great for your exam or if you're going into grade 11 chemistry, because you really need to know that. But let's just do a quick review. We're just going to do 3 questions and 3 questions for naming and writing the formulas. Okay, so let's start with naming. So name the following. So here we have lead. So lead is right here. It is a transition metal. So we're going to write lead. Then we have oxygen, but we change that to oxide. Change the ending to IDE. But because lead is a transition metal, we need to write its charge in Roman numerals. So oxygen is here. So it has a charge of -2. Okay, you have to sort of remember your pattern with charges here, right? +1, +2, +3. plus or minus 4, minus 3, minus 2, minus 1, and 0. So oxygen is in this column, so we have minus 2, and we have 2 oxygen atoms. So that's a total charge from oxygen of negative 4. Now we only have 1 lead, and so the charge on lead needs to balance that negative 4 charge from oxygen, so it needs to be positive 4. So we have lead 4 oxide. The next one we have calcium. Calcium's right here. It's not a transition metal. Its only charge is positive 2, so we do not need Roman numerals. So we have calcium. Okay, and then this is a polyatomic ion. Please do not write calcium, oxygen, hydrogen. That would be wrong. That's the polyatomic ion hydroxide. So we have to write calcium hydroxide. All right, next we have a molecular compound. I know it's molecular because there's no metal. So when we have 2 non-metals, we're going to use those prefixes: mono, di, tri, tetra, penta, and so on. So we have 2 nitrogens. So I'm going to say dinitrogen. And then 5 oxygens. So penta for oxygen, and then oxygen will change to "ide" at the end, so pentoxide. So dinitrogen pentoxide. All right, now let's try right formulas. So here we have lithium and fluorine. Lithium is here, and so has a charge of positive 1. Fluorine is here, and so has a charge of negative 1. You need to figure out how many atoms of each are required so that your total charge becomes neutral. Right? In this case, it's easy. One positive 1 and negative 1. We only need 1 of each. So that's just LiF. Okay. Next is iron 3 fluoride. So iron is Fe. It is transition metal, or has multivalences, but we're told what its valence is. Positive 3. Fluorine is negative 1. So now to balance this, I'm going to need 3 fluorines to make that negative 1 charge balance with positive 3. So it's going to be FeF3. All right, now this one has our prefixes, so we don't even need to worry about charges. So diphosphorus, so 2 phosphoruses. Pentaoxide, 5 oxygens. Okay, if you need more help with nomenclature, go to my channel and you can look up nomenclature. I have a full video on all the types of nomenclature. Next, balancing equations. We'll go over some examples here, but again, I've also created full videos on balancing equations and identifying the types and predicting the different reactants based on what type of reaction it is. But for these, we're just going to go over them. We're going to balance, and then we're going to classify each type. So let's balance part A. So let's just count. Here we have 1 potassium and 1 potassium, so that's fine. Here we have 1 bromine and 2 bromine, so that's not fine. So we need 2 over here, but do not put a 2 there, because then you're changing what the reactant actually is. We don't want to change what the reactant is. We want to change how much of it we have so that all of our atoms are balanced. So we're going to put a 2 here. Now, yes, I realize that messes up with potassium, because potassium's no longer balanced now. That's okay. We can put a 2 here to fix that. Only ever change the coefficients, not the subscripts. Okay, that's how we balance. So what type of reaction? We have 2 simple elements combining to form a compound. So this is a synthesis reaction. All right, next, here we have hydrogen peroxide breaking apart into water and oxygen. All right, let's try hydrogen 2 here and 2 here. Okay, oxygen 2 here. We have 1 here and 2 here. That's a total of 3. This is not okay. So what do we do? Okay, I could put as many coefficients over here, but I'm only ever going to get an even number because any integer multiplied by 2 is an even number. So what I'm going to do is I'm going to put a 2 here. So that changes this 1 oxygen into 2. So it forces me to have an even number in our reactants because now I have a total of 2 oxygens here and 2 oxygens here. So 4. Since I have 2 here, I can now put a 2 here to give me 4 oxygens. And our hydrogens are still okay as well. 4 hydrogens, 4 hydrogens. So it's balanced. So what kind of reaction is this? Well, we're taking something complex and we're breaking it apart. So this is a decomposition reaction. Any questions so far? Doing a lot of talking. All right, C. Let's start with iron. I usually like to leave, if possible, hydrogen and oxygen till the very end because they're the ones that can be the most confusing. So instead of starting with hydrogen and oxygen, let's start with iron. So I have 1 iron here and I have 2 here. So I'm going to put a 2 here. Now, this is sulfate. When we have a polyatomic ion that remains like so, so we have SO4 in our reactants and we have SO4 in our products. When that happens, it's a lot easier, instead of counting sulfur and oxygen separately, to count them as polyatomic ions. So here we have 1 sulfate ion. Here we have 3 sulfate ions. So I'm going to want to put a 3 here. Now when I do that, I now have 6 hydrogen here, but only 2 here. So I'm going to put a 3 here. And now that's balanced. What type of reaction is this? In this case, we had this sulfate leave the hydrogen and come over to the iron. So this is a single displacement reaction, sometimes called a single replacement reaction. It doesn't matter which one you use. All right, moving on. So we got propane. So we got a hydrocarbon. Anytime you take hydrocarbon and mix it with oxygen, you know you're going to get carbon dioxide and water. I'm just going to jump ahead and say this is a combustion reaction. So let's balance it. So let's start with the carbons. We have 3 carbons here and only 1 here. So I'm going to put a 3 here. Now I have the same issue as before, right? I only have 1 oxygen by itself, but over here I have a 2. So I'm going to force this one to be even for now. And I can do that by first balancing hydrogens. So here I have 8 here and only 2 here. Okay, if I have 8 here and 2 here, I'm going to need a 4. So that gives me 8 hydrogens and also 4 oxygens. So I no longer have an odd number, which is good. So I have 4 here and 6 here because the 2 times the 3. So I have 4 and 6. 10. So I'm going to want to, I'm starting to get tired. It took me a moment. I'm going to want a 5 here to balance that one. Hold on, I have a question. PbO2 could be called lead dioxide, couldn't it? So yeah, there are a lot of exceptions to the naming rules, and we start to come across those exceptions in like grade 11 and grade 12. For example, like HCl. Well, if it's an aqueous solution, it's hydrochloric acid. But if it's not aqueous, some people might want to call it hydrogen monochloride. But a lot of the times we don't put mono in it. We just say hydrogen chloride. So there are a lot of exceptions to the rules, yes. But in grade 10, we're just starting to learn nomenclature, so I tell my students not to worry about those exceptions. Okay, moving on. So here we have lead nitrate, so lead 2 nitrate, potassium iodide, and we're getting lead iodide, lead 2 iodide, and potassium nitrate. So what's happening here is we are getting sort of a double switcheroo. The nitrate and the iodine are switching over. So this is going to be our double displacement reaction, also called a double replacement reaction. It doesn't matter which one you call it. Okay, so let's balance it. Start with lead. So 1 lead and 1 lead. That's good. Okay, look at the nitrates separately. So we have 2 nitrates and 1 nitrate. Be careful, it's not 3. Look at it at the nitrates separately. It's just 1. So I'm going to put a 2 here. Well, now I have 2 potassiums and only 1 potassium. So I'm going to put a 2 here. But that works out for iodine, because now I have 2 iodine and 2 iodine. Looks good. Anyone have any questions? No? Okay. I suppose in grade 10 you don't use the term stoichiometry. No, no, we don't use the term stoichiometry. They are first in Ontario. They're first introduced to stoichiometry in grade 11 chemistry. Yeah, so they have no idea what that would even mean. No. Stoichiometry is a lot of fun though, but yeah, not in grade 10, grade 11. Okay, so problem solving type questions. Chemistry. A solution of sodium hydroxide has a pH of 10. Okay, that would be a base. Describe what happens to the pH of the solution as hydrochloric acid is added. All right, so if you're adding an acid to a base, that pH is going to drop down. You're essentially going to try and neutralize it. Okay, but if you keep adding more and more and more of the acids, then once you neutralize it, now it's becoming more and more acidic, right? So what's happening is you're dropping the pH by doing that. Then it says write a balanced chemical equation for this reaction and identify the type. I've already hinted towards what type it is when I said you're neutralizing it. This is a neutralization reaction. So that's the type, a neutralization reaction. Right, and now let's write it out. So we have sodium hydroxide, NaOH. We'll put in our states, but the grade 10s don't need to worry too much about the states, not until grade 11. Plus hydrochloric acid, although I do insist if they're doing an acid, always write aqueous. And that is going to give us, so in a neutralization reaction, grade 10s should know you get a salt or an ionic compound and water. So our salt is going to be NaCl. So we get sodium chloride plus water. Okay, then we have to balance it. I think it actually looks pretty good anyways. So you have 1 sodium, 1 sodium, 1 chlorine, 1 chlorine. Here we have 1 oxygen, 1 oxygen, 2 hydrogens, and 2 hydrogens. So that's already balanced for us. Okay, which is fine. For grade 10s, sometimes my students will see a question that will say balance this, and it'll already be balanced, but they feel like they have to write something. So they just start throwing in coefficients. Don't worry, if it's already balanced, this is probably one of the only times where you can actually get marks for writing nothing. Okay. All right. Physics. So in physics, we find images. So let's go over how to find images in both curved mirrors and in lenses. So there are a couple rules. I'm going to go over the 3 most common ones, but you only really need 2. So if you're doing this question on a test, you only need to use 2 of them, not all 3. But I'll use 3 so that you can see what they are. So the first one, you're going to draw a line parallel from the top of our arrow here. This is our object. This little arrowhead is our object. So from the top, we're going to draw a line parallel to the principal axis. This is our principal axis, this line here. So parallel. Okay, it kind of went down as I let go of the mouse, but whatever. It's not going to be perfect. And then it's going to reflect through the focus, like so. Then always draw your arrows so that you know the directions. Because what you're looking for is where the reflected rays intersect. Only the reflected rays. The second one, which is the easiest to remember if you know the first one, is the exact opposite. So we're first going to go through F, like so. And then we're going to reflect back parallel to the principal axis, like so. So draw your arrows. And the reason why I say it's important to draw your arrows is because sometimes students will look at this and say, ha, they intersect right there. It's like, no, they do not. You have to look where the reflected rays intersect. This would be one reflected ray and one incident ray. No, the 2 reflected rays intersect here. So that is where you are going to draw your arrow, like so. Okay, and since we started at the tip, where they intersect is where the tip of your arrow is going to be. Now the third one, I don't think will fit on this diagram, but let me just introduce it. If you go through the center of curvature and hit the mirror, wherever that mirror, yeah, it's not going to fit. The mirror doesn't go this low. But if you hit the mirror, it would reflect back on itself. That was obviously horrible because I don't know where the mirror is, because it should go through this point as well. So let's just use those 2. All right, so characteristics. Here's our acronym, S-A-L-T, SALT, for size, attitude, location, and type. But I've also heard of the acronym, I believe it's LOST, for location, orientation, size, and type. Either way, you're identifying those 4 things. So the size, okay, you'd have to take a ruler, because these look pretty close, the object and the image. But I'm going to say it's a little bit smaller, just because I know that it should be. Attitude, well, it's inverted, it's upside down. Right? So this one's upright and this one's the opposite orientation. So we can say inverted. Location, so where is it? So this is C and this is F. It's in between them. So between C and F. And the type. So you have 2 options for the type, real or virtual. A real image is if light rays actually intersect at that point. Okay? A virtual image occurs if light rays are diverging and hit our eye. And then our brain sort of transposes those backwards to where they would have intersected. But they don't actually intersect. Our brain just assumes that and creates an image for us to see that's not actually there. Those are virtual. So in this case, we can see they're definitely intersecting. They're not diverging. They're intersecting right at this point here. So this is a real image. Okay, let's try a lens. So for your lens, a lot of the times when I give students problems, I already have it drawn. But if it's not drawn, you're going to have to draw your optical center and your vertical line through it. Like that, somewhat. Okay. Oh, hold on. I have questions. I'm going too fast. What is the CC point? Oh, center. Yes. So CC is the center of curvature. Sometimes in diagrams, it's just labeled as C. It's usually equal to, it's not usually, it is equal to twice the focus. When we're dealing with lenses, we don't have CC. There's kind of a point here. We have 2F. Okay. This would actually be F primes, and these would be F and 2F. So with a mirror, it's curving, and if you extended that all into a sphere, the center of that sphere would be our center of curvature. But for lenses, we have an entire ellipse, sort of, and the center, this is called our optical center. So these points are just 2f as opposed to c. The rules are fairly similar though, so let's go through them. First, you draw one parallel to that principal axis. Same thing, this is our principal axis. Now in this case, it's not going to reflect through f because it's a lens that's going to refract through f. So from this point, we're going to have it go through the lens, refracting, and through that focus here. And we can draw our arrows. Okay, that's the first one. The second one goes through f prime. We're just barely hitting the lens here. And then parallel to the principal axis. So there's our second one. And if you need to, your third one goes directly through your optical center without refracting. Oh, this one worked so much better than the last one. Now you don't need to do all three. You only need to do 2 of the 3 because you're just looking for where those refracted rays intersect. So in this case, our image is here. So using our same acronym, so size, this one's, don't even need to measure, it's clearly larger. Attitude, it's inverted or upside down. Location, this one's beyond 2f. And type, this one is still real because those refracted rays actually intersect. Okay. Did anyone actually, I don't think I prepared an example of virtual. Did anyone want to see an example of a virtual image? No? Yes. Okay. Let me just undo all of this, and then I'll put in a new object, and we'll do an example of what a virtual image would be. Okay. So what I'll do then, let me erase. Oh, I can't erase that. I'm just going to create a new object. This object I'm going to place here. So this will be the object we want to find the image for. We're going to use the same lens and everything, but we're going to look for that object. So let's do the same rules. We're going to start here at the tip. We're going to go straight and then refract through f. So far, so good. No difference. Now the second one becomes hard because you'd have to go through f prime. But if you go through f prime, you're never actually hitting the lens. So what you could do is you can imagine a ray coming from f prime, like this. So coming from f prime, hitting the top of our object, and then it's going to get refracted back parallel, sorry, not back, refracted through parallel to the principal axis. If you don't like doing that one, a lot of people don't like doing that one, the third ray is obviously a great option. If it goes through O, it just doesn't refract at all, it just keeps going. But notice these 3 refracted rays are diverging. They're getting further and further apart. They will never ever intersect. So you're never going to get an actual image. But imagine these rays hit your eye. So let me draw a gigantic eye right here. So there's your eye. And you see these rays. So what your brain does, I'm going to change the color. What your brain does is it imagines these rays traveling backwards because your brain only knows that light travels in a straight line. So it takes these three rays and sort of translates them all backwards. Kind of trying to make them somewhat straight. Close enough. This won't do that one. So if you translate them backwards, your brain actually forces them to meet. And so your brain then creates an image right there. Okay, now those light rays don't actually go there. Your brain's just assuming they go there. So that's the one we call a virtual image. Okay, if you wanted to complete the characteristics here, it's larger. It's upright, so it doesn't get inverted. And the location, I would just say the same side as the object, right? It's not on the other side of the lens, it's on the same side. So what is this used for? This is a magnifying lens. Magnifying lens. So a magnifying lens is a converging lens, but you place the object extremely close to the lens, closer than its own focus, when you look through it. Right? And that's where you get your virtual image. Is that good? Any questions? Okay. Awesome. So now we're going to do some problem solving. There are a few equations we use in grade 10. Some students love the math, other people do not. What's 2f? Why is it relevant? So 2f really isn't relevant to help us find where the image is, but it helps us to describe locations of images. Especially with converging lenses, because we get different properties depending on where the object is. If it's placed beyond 2f, we get an image that is actually smaller. If it's placed at 2f, we get an image that's the same size as the object. And if it's placed between f and 2f, you get an image that is larger. Right? So it's fractions. So we use this formula. The index of refraction equals c over v. Okay, so n represents the index of refraction, and in this question it's saying diamond has an index of refraction of 2.42. And then it says calculate the speed of light in diamond. So v is the speed of light in a certain medium. Light. Stream got laggy for me. Is it okay now? I hope it's okay now. Okay. So speed of light in a medium. C is the speed of light in a vacuum. Hold on, I'm just getting some errors. Is everybody still able to see and hear me? I'll just pause for a minute. Everybody hear me okay? Is it still working? Or did I lose the live stream? Okay. Okay, that's good. I'll continue. Okay, so c is the speed of a light in a... Now, this question, students get a little confused because they look at it and they say, how am I supposed to calculate v if the only thing I know is n? Okay, 10 to the power of 8 meters per second. And that is something I asked them to remember. Okay, so there's only two types of questions I can ask here. I can give them n and ask for v, or I can give them v and ask for n. In this case, I'm giving n. This is what n is. N does not have any units. Okay, it's just an index. So it's just 2.42. That's it. Both c and v are speeds and so have units of meters per second. Now, if I need to rearrange for v, all I'm going to do is a little cross multiplication switcheroo here, and I'm going to write it as v equals c over n. Okay, now another place where students get messed up with is the exponents and working it on their calculator. So here's a couple hints. Times 10 to the 8, let me just write this in, over 2.42. Here's what I suggest if you are not good with your calculator. Put this on your calculator. So if I take my calculator and just do 3 divided by 2.42, I get 1.239 and so on. So I'm going to round that to 1.24. Okay, and then put this back in, times 10 to the 8 meters per second. There you go. Now it's easy. Now if I were doing it the other way around and I gave you this and I asked for n, well then again it's really easy. So n would be c over v. So let me show you what you would do on your calculator, because some students end up getting times 10 to the power of 16, and I know why they're getting it. But if you did this, students that get times 10 to the 16 are ones that do not put brackets when they're punching it into their calculator. And so they're doing 3 times 10 to the 8 divided by 1.24 and then multiplying by 10 to the 8. Easiest thing to do in this case is, notice that if we have 10 to the 8 divided by 10 to the 8, cancel it out and only put this onto your calculator, because then it's just 3 divided by 1.24 and it becomes really easy. Do you give light speed value with the questions, or do they have to know it by heart? The speed of light in a vacuum, I asked them to know that by heart. The equations I give them, in grade 10 we actually give them the equations, but speed of light I just find to be so important in physics, I ask them to know that one by heart. Okay, next one is what we call the thin lens equation. Okay, it looks like this, where we have 1 over f equals 1 over do plus 1 over di. So f is our focal length for whatever lens we're working with, and do is the distance to the object, and di is the distance to the image from that optical center of your lens. So in this case, we have a converging lens, has a focal length of 13 centimeters. So we're being given f. So f equals 13 centimeters. If a loonie is 20 centimeters, so that's just a coin. It's a dollar coin in Canada, if there's any non-Canadians here. It's just a coin. Is 20 centimeters from the lens. So that's the object. So it's telling us do. So do is 20 centimeters. Calculate where the image of the coin is. So we want to find di. Okay. Now do is always going to be a positive value. F can be negative for diverging, no, not can be, is negative for diverging lenses. But in this case, we don't need to worry about that because it says it's like converging lens. So the values are just going to be positive. Okay, so if I plug them in, so we have 1 over 13. I usually insist we write the units, but when I write units, students get even more confused. So we'll just, everything's in centimeters and we'll add it back into the end. Equals 1 over 20. What's that? A loonie. Yeah, I know. And the $2 coin's called a toonie. Plus 1 over di. All right. So first thing we want to do is, since we're solving and isolating for di, oh, this has so many words students don't like. Isolate for di and fractions, but we try to get through it. So we're going to bring this term to the other side of the equation by subtracting it from both sides. So if we're subtracting it from both sides, we get 1 over 13 minus 1 over 20 equals 1 over di. So now you have the option. Calculators are allowed in my class. So if they know how to use fractions on their calculator, you can do 1 over 13 minus 1 over 20. Or you could, if you like fractions, just work with the fraction. Right? Find a common denominator. So multiply this top and bottom by 20. Do top and bottom here by 13. And then we end up with a common denominator, which would be 20 times 13, 260. And we end up with 20 minus 13. Yeah, see? It's okay. Fractions aren't that bad. So 7. Now, here's where students go wrong. They're happy. They dealt with their fractions. I'm good. Next question. They forget that they haven't solved for di. They've only solved for 1 over di, and that's not what the question is asking for. So at this point, what you want to do is flip both sides. I find that the easiest. Or in fancy math terms, take the reciprocal of both sides. Okay? And that's going to solve for di as 260 over 7. Okay, you can put that on your calculator, divided by 7. So we get 37.1, so 37 centimeters. And now they're finished the question. Okay, so that's a good review of biology, chemistry, physics, which is optics, for grade 10. There is another part of grade 10 science, which is climate change. So I have a couple questions we can go over. If any of my students are watching, I know we ran out of time. We didn't get the climate change. So don't freak out. This is not on your exam this week. But if there's anybody who does need to practice some of these, here are some climate change questions. So, natural sources of atmospheric carbon dioxide include, this is important, all of the following, except volcanic eruptions. Yep, that's a natural source of carbon emissions. Burning of organic matter, sure. Forest fires. Photosynthesis, no. Photosynthesis uses CO2, and it doesn't create it. All right, 53. Which of the following gases, again, all are able to trap infrared radiation? Water vapor, yes. Nitrogen gas, no. I mean, nitrous oxides can, but just by itself, no. Methane, yes. So this has one no because it says all, so no. Carbon dioxide, water vapor, not oxygen, no. Okay. Carbon dioxide, methane, not oxygen. It better be D. Water vapor, carbon dioxide, and methane. There we go. And if you're curious, these are the main sources of greenhouse gases: CO2, CH4, different nitrous oxides, ozone, water vapor, and CFCs. Next, Earth climate system is powered by the sun. If there was no sun, entropy would destroy us all, right? So, yeah, most important thing for our ecosystems is the sun. And some different types of problem solving. This is one I usually like to put, is what's the difference between weather and climate? Okay. I love the phrase, I don't know who first said it, but I love climate is what you expect, weather is what you get. Okay. So, put more properly, climate is the average or variations of weather over a long period of time, so years. Right? So if you're looking up in Canada, you would expect snow in January. Maybe there's one day in January where it's sunny, hot, and 20 degrees. That would be wonderful. But that's not what you expect. That would be what you would get. So that would be the weather, not the climate. Okay, so that's our difference there. Weather is looking at a course of hours to days. Climate is looking at averages over years. And last question, the greenhouse effect. Okay, I think we all know the greenhouse effect, hopefully. The sun gives us energy, and we give off the same amount of energy. Okay, we use the energy we get from the sun, and then we give it off the same amount in different forms. Okay, so we have like a nice net zero effect here on Earth. And that's very, very important. I get a lot of students saying, oh, the greenhouse effect is so bad. It's like, no, it's very, very good. The moon does not have a greenhouse effect, right? Because it has no atmosphere, so it doesn't have any controlled climate. So when the sun's hitting it, it's like hundreds of degrees, and when it's not hitting it, it's like minus hundreds of degrees. Right? That would be horrible for life. Right? So the greenhouse effect is extremely important. We love the greenhouse effect. What you don't want is to get away from that net zero effect. So like Venus is a runaway greenhouse effect. Right? It's why it's even hotter than Mercury, even though Mercury is closer to the sun. And it's because it's not giving off as much as it's getting. And if we start doing that to the Earth, well, hopefully we never get to be as bad as Venus. But there we go. How have humans' activities altered this effect? Oh, put short, the Industrial Revolution. The magnetic field saves us too. Yes, our magnetic field does save us. I find it interesting with Mars, where Mars used to have a magnetic field, just like Mars used to have like oceans of water, and they lost their oceans around the same time they lost their magnetic field. That's an interesting coincidence I always find. So thank you, magnetic field. Okay, I am almost losing my voice. It's been a long exam review. How long have I been going? It says somewhere. I don't know. It's been a while. I hope that review session was helpful to everyone. If you ever need to go back and look at it, it should just be on my YouTube channel. And if there's no questions, any last minute questions? If not, I hope everyone enjoys their Sunday, and good luck on all their exams if you have exams coming up.